Kia ora, Year 12 and 13. This is question 2 from the 2015 exam. It's just the first part, so it's questions A, B and C, so 2 achieved questions and then a merit question. Okay, here's the first one. Find this integral here. Let's see what we've got. Okay, so the first thing we need to do is to rewrite it so that we have everything in the numerator. So we're going to rewrite that as 3 minus 5x to the negative 2 dx. It makes it pretty straightforward to anti-differentiate. So we get 3x. Now here, I want to have x to the power of minus 1, but I want to end up with a minus 5 here. When I differentiate, I'm going to pull down that negative 1, and that will give me a minus. So that means that here I'm going to want to have a plus 5, plus c. As usual, when you anti-differentiate, you check back by differentiating. So there's no need to ever get a wrong answer. So differentiating that, we'll get 3, which works, minus 5x to the negative 2. So that looks good. Okay, on to the next one. Alright, use the values in the table below to find an approximation to the integral from 1 to 2.5 of some function. And we're going to do the trapezium rule, and we've been given this table of values. Now I've stuck in for you what you get in the formula sheet, which is the trapezium rule. So things that we need to have are, we need to know what our h is, which is the width of my intervals along here. So in this case, the jump from one to the next is 0.25. So we're going to have h 0.25. My y values come from the values in the f of x row. I'm going to have one lot of the two endpoints and two lots of all those middle ones. So that gives me a is equal to 0.25 over 2 times 0.3 plus 1.1 plus two lots of all of that other stuff. Very messy, sorry about that. Right, there we are, 1.7. And if we add all of that up, what we should find is we get 0.25 over 2 times, the first bit is 1.4, and then the middle stuff, well, let's have a look. We've got 0.7, 1.9, so 2.6, 4.3, and those two add to give us 4, so that's 8.3. Two lots of that is 16.6, right? So the whole lot inside the brackets is 18. I know you're just going to do that on your calculator. Just be very careful with your brackets when you're doing trapezium rule. And that gives us the area, which is 2.25. And we should just write units squared. Right, on to the merit question. Okay, this is a kinematics problem. You need to read it quite carefully to check you understand exactly what you need to do. So, an object originally moving at a constant velocity suddenly starts to accelerate. From the start of the object's acceleration, the motion of the object can be modelled by this differential equation. Okay, and this is true between 0 and 20 seconds. So 0 seconds is when the object started to speed up. And we're told that the original velocity was 6 meters per second. So we can write down at t equals 0, v equals 6. And our goal is to find out v at t equals 4. Now if we take a close look at the dE, we can see it's not a nasty one at all. We've just got one variable here, and it's t. So step 1 is to just rewrite that equation. So we've got 50 t squared over 5 root t minus 80 root t over 5 root t. So that first term collapses to 10 t to the power of 3 over 2 minus 16. Now to find velocity, we are going to anti-differentiate, so we'll get this I'm going to anti-differentiate 10t to the 3 over 2 minus 16 with respect to t. I'm going to go on to a new slide. Okay, so we had this. So anti-differentiating, I'll get something times t to the power of 5 over 2. Right, I want to have 10 up here. So it's going to be 10 times 2/5 to undo the 5 over 2. Right, we'll come back and clean that up in a minute. Minus 16t plus c. And that's now giving me an expression for velocity as a function of t. So we get v of t is equal to 4t to the 5 over 2 minus 16t plus c. Now we know that when t is 0, v is 6. So we're going to substitute those points in. We have 6 is equal to 4 times 0 minus 16 times 0 plus c. So c is 6, which tells me my equation is v of t is equal to 4t to the 5 over 2 minus 16t plus 6. Now we need to work out v at 4. So 4 times, well, let's do this in our head. So 4 to the power of 5 over 2, 4 to the 1/2 is just the square root of 4, so that's 2. So 2 to the power of 5 is 32. So 4 times 32 minus 64 plus 6. So that works out to be 70. And our units for velocity is speed, so it's meters per second. So you can write it like that, or you can write it as 70 ms to the negative 1. Be really careful with your units for these questions. In the schedule last year, it didn't matter if you got your units wrong, but you should all have a good understanding that speed here would be meters per second. Okay, thanks for watching. I'm about to do a video of parts D and E in last year's paper.